So we're now looking at the technique of solving a quadratic equation using the square root property. And this is material that can be found in section 8.1 for intermediate algebra, MAT 1033. So this technique here can only be used. This technique can only be used. It can only be used for a quadratic equation. Quadratic equation of the form ax squared equals b, and a and b here, they are coefficients. These are coefficients. They are numbers, right? And then the x here is the variable to solve for, and x is the variable to solve for. Solve for. Okay. So now, the real fundamental of this using the square root property, the real fundamental of this technique is that when your equations, is in the form just simply an x squared or some expression square, some perfect square on the left side equals to a number, a positive number. I mean any number is being equals to a number on the right side, right? Then what you can do is, to solve for x, right? All you have to do is just simply to solve for x, all you have to do is just take the square root of b on the right side. And then not just a square root, we have to take two square roots. Positive square root and a negative square root. So we do x equals plus or minus, plus and minus square root of b. And that is simply the square root property. Okay? So, and once again, this square root property here can only be used for the equation that's simply, ax squared equals b, right? Okay, so now I'm going to start looking at the first example here. The first example of how to solve an equation using the square root property. Okay, so we can look at example 1 right here. Okay, for simplicity, I solve my equations. X squared equals 25. Okay, so what I can see here is this equation is exactly in the form. This equation here is in the form simply an x squared on one side, right? A square on one side and a number on the right side. That is it. A square on one side and a number on the opposite side. So now I can just use those to solve for it. All I can just use for that. All I can just do is x equals plus and minus square root of 25. Okay, and so that means x here. What is the square root of 25? 5, right? So that means the value for x is x equals plus or minus 5. Okay? So really in the end, your x value is 1 above being 5, right? And x equals negative 5. Those are the two solutions. Right? So this is the square root property. Right? So now we can look at another example. In example number 2, you can look at example number 2, things can go a little more complicated. How about we got 2x squared, okay, equals to like a, you can think of like a, let me see, 18, okay, 2x squared equals 18. So now on the left side here, I do not have just simply a square. I have a square and a coefficient in front of that. Okay, I have a coefficient in front of that. So what I need to do is I need to bring it back to just simply the form x squared equals a number. Okay, that's where I can use the square root property. But here I don't have just simply x squared. I have a 2x squared. So what I need to obtain here is that I'm going to need to divide both sides here. By the way, this is a solving problem. So I need to divide both sides here by 2. And so now, divide both sides by 2 here, I'm going to get x squared stand alone by itself. That's where I'm happy on the left side. So on the left side now, the 2 cancel with the 2. I got x squared. And then on the right side, 18 divided by 2, I got 9. Okay? So now I'm back to the traditional form. To the form of x squared on one side, a square on one side, and equals to a number on the right side. Okay? So now, with this, when I bring my equation into an x squared or some expression square on the left side, now I'm safe to use my square root property. So what I have here is x, using the square root property, equals to plus and minus square root 9. Right? And that means it equals to plus and minus 3. So really our solution here is 1 over the x is positive 3. One solution for x is x equals 3, and the other one is x equals minus 3. That are our solutions to this starting problem. Okay? So in my next example, how about this time? Okay, so how about this time? We are trying to solve. How about we got x squared plus 4 equals 0. Now we try to solve this quadratic here. So now this quadratic right here, at the starting point right here, it does not look like the form that we're looking for, right? It's not in the form of an x squared on the left side and a number on the right side. So we, as a starting point, right, what we need to do, the starting equation x squared plus 4 equals 0, we need to bring the number to the other side, to the opposite side, because we only want just x squared alone by itself on the left side. So the way to do that, I'm going to subtract 4 to both sides. So I'm going to end up with x squared equals minus 4. Now I'm back to the form of a square on the left side and equals to a number on the right side. Okay? I can just now simply use the square root property. So to solve for x equals plus or minus square root of minus 4. Now wait a minute. Can we take the square root of negative 4? The answer is before chapter 7. No. But now since you already learned chapter 7, yes, because you know how to handle the square root of the negative numbers, right? Remember the imaginary number, the I. So what I have here is square root of negative 4 is a 2i. Okay? If you don't know how I got the 2i here, make sure you go back and review the complex number that we learned in class. Right? And then the answer here is a plus or minus 2i. So meaning your solution here, one of them is a positive 2i. Okay? And the other solution, x equals minus 2i. Okay? So yes, that is another example of how you can solve a quadratic equation using the square root property. Okay? And then in another example, you can see in another example, okay? This time, how about we want to solve, okay? But instead of having simply an x, I have like an x minus 3 all square and equals a 16. Now, at first it looks a little bit troubled, I would say, but then don't be panicked. The point now is that even though it's not simply an x squared, it's not just simply an x squared equals a number. Okay, it's not just simply an x squared equals a number like what we want, but then think about it. You can treat the whole x minus 3 here as 1 units, right? So what we do have something all squared equals 16. So the square root property is still going to work this time. So the point I'm trying to say is on the left side, it's still in the form of a square. It's still in the form of a perfect square. The whole x minus 3 here, square. So using square root property, okay? Using square root property. What I can do with this? Now, my starting equation, x minus 3 all squared, right? You can see all x minus 3 right here as 1 unit, and it's being squared, equals 16. So what I can do is I can take this, I can just simply, x minus 3 itself, using the square root property, right? X minus 3 itself equals to, on the right side, I'm doing plus and minus the square root of 16. Okay? So now, which would be equals to, which would be at the same time equals to plus and minus 4, because square root of 16 is 4. And so now, but then I don't want x minus 3 equals plus minus 4, I want to solve for x. So at this point here, I'm not done yet. So I need to add 3 to both sides. Okay? I need to add 3 to both sides. So now my remaining equation here, the 3 on the left side now is cancelled out. So x equals to 3 plus and minus 4. What does that mean? It means, first of all, the first x value here is going to be 3 plus 4. Once again, I repeat, the first x value for this equation here is going to be 3 plus 4. So I got 7. That's my one solution to my equation here. My second x value here that I can find is going to be 3 minus 4. So x is equals to negative 1. Okay? And that's how I solve my quadratic equation, another quadratic equation using, it's a special form using the square root property.